Okay, so let's look at the various ocean layers. Now, one thing important to remember here is that the deeper you go, the colder you get. And that's because sunlight only travels down about maybe 200 feet. So once you get beyond that, we're not getting any light to warm up the water. So the temperature starts to drop. And as the salinity will also change and the density will also change. About 2% of the ocean is what we call the mixing zone, where the water temperatures and the solutions blend in together. Then we go down a little deeper, we get to what we call the thermocline, where the temperature decreases because you don't get any surface motion. And then when you get a little further down, you get into what we call the deep cold zone, where the water temperatures are actually very near freezing, but it's so salty it won't freeze. So that's what it looks like. So there's your mixing zone. Go down a little deeper, about 1 kilometer down, you're in the thermocline transition zone. And then a little deeper than that, down around 2 kilometers in depth, you're into that cold zone, which is about 80% of the ocean. So notice the temperature curve. So we can be at 20 degrees centigrade there, and it'll go down to just really close to freezing when you get all the way down to the bottom. And then the salinity also, 37 at the top, and then it'll start to decrease as we go down. We all know about, especially living on our coastline, we know about pollution and oil spills. And again, a lot of accidents can damage that. Here's the map from the book. There'll be some questions on the test about this. And notice, all, Gulf of Mexico, all along our coastline here in California, and all around the world, we see these oil spills. There we are. Actually, yeah, that's Santa Barbara. I take that back. That's Santa Barbara, but you can see there the effects of what would happen if the tide goes up. It would cover a lot of this. And just what the bathymetry, what it looks like underwater off our coast up here. So here's the coastal islands here, and then here's where we are. There's Los Angeles down there. That's the Ventura Plain, or the Oxnard Plain. Sorry about that. Okay. All right. Now, the main thing that we want to talk about is the coastal system components. So again, lots of animations on this. So make sure you go over there and watch this. There's a video, video on beach processes and sand transport. Make sure you watch this. That one on longshore sand drift and transport animation. Watch that and all that. So you want to be aware of what the coastal environment is. This is all in your book, so make sure you cover that in the book because it's all going to be all over the test. Know the definitions of the littoral zone, the immediate coastal and shallow offshore areas. The shoreline is just the line of contact between sea and land, and the coast continues inland from the point of high tide to the first major landform change. That's the coast. Sea level, now you probably all wondered, well, what is sea level? Well, it's the value based on the average tidal levels recorded hourly at a given site over many years. It's going to vary daily, and it varies with the change in climate. You can look on the news, look online, and it'll always tell you, what the high and low tides are, and then the average of those recorded hourly over the course of the day will give you the MSL, the mean sea level. So this is in your book, so make sure you know these. High tide, low tide, the surf zone, the coastal area, the coast itself, the beach, how deep it goes, and so forth, because all this will be important when we look at tides and waves. So pay attention to that, okay? And there's going to be questions on the test about that. So it's figure 11.9, so people pay close attention to that. Now, the tides in the module, there's one on the tidal cycle animation. Make sure you watch that because it will explain the spring and neap tides. Okay, the spring tides and the neap tides. So there's an animation that will cover that. So make sure you watch that. And it'll also give you a couple examples of what it looks like, in the Bay of Fundy, which has the highest tidal range in the world. And you can watch those. It's time lapse, and it will show you the rise and fall of the tides, which is kind of cool. And it's all due to the gravitational pull of the sun and moon. The sun's influence is less, simply because the moon is closer. So we get these tidal bulges, these areas of raised water, and that's why the equator the circumference of the Earth is bigger around the equator than it is from pole to pole. One side is on the moon, and one side facing away from the moon. And the difference between the high and the low, that's your tidal range. And like I said, the Bay of Fundy has the biggest in the world. So watch those two videos; they're pretty cool. Play this tide animation so you know what they're talking about. The differences between spring tide, and it doesn't mean it happens in the spring. It just means that the water springs out based on the alignment of the sun and the moon. So, you can have it when they're both on the same side, and when you have a full moon on the other side of the Earth. And then the two neap tides, the lower tides, are the first and third quarters where the moon is on either side of the Earth. Okay, so know the difference between these. And this is just here's an example, where Nova Scotia, which is near the Bay of Fundy, so there it is at high tide, and there it is at low tide. And watch these in the weekly module, because these are time lapse, and it's pretty cool how it works. Okay, so that we'll stop there and do waves in the next section.